to record so that I can upload them to YouTube and put in your Google Classrooms. So in case you're absent, you can always check there. I didn't really record yesterday because yesterday we were kind of just going over what we had done the day before and getting into ALEKS. So that's all we did yesterday. And looking at some of the ALEKS workbook expectations. So we're going to start by looking at what we know. Be sure you put your name somewhere on this packet. It would probably be advantageous of you to write 4th hour and Mrs. Log somewhere, as well as other 7th graders will also have this packet around. If someone sees it, they'll know who to get it back to, which would be me if they don't know who you are, right? So we're going to place a check mark in each row that corresponds with how much you already know about each topic, even before we start this module. We know we did the pre-test. Hopefully that's done. That's what we did yesterday. If you haven't done that, the sooner the better, right? Because now you're starting to learn information. So it's not really a pre-test if you haven't done the pre-test before we start learning. So here the square means I don't know. The diamond is I've heard of it. And the star is I know it. We're looking at just the 3 before columns. So computing unit rates involving ratios of fraction. You're either putting a check in I don't know, heard of it, I know it. The next row, determining whether a relationship is proportional by looking at a table of values. We're checking I don't know, I've heard of it, I know it. The third row, determining whether a relationship is proportional by looking at a graph. Either I don't know, I've heard of it, I know it. The fourth row, finding and interpreting the constant of proportionality. Either I don't know, I've heard of it, I know it. Interpreting the points 0, 0 and 1R on the graph of a proportional relationship. Either you don't know, you've heard of it, or you know it. Representing proportional relationships with equations. Either you don't know, you've heard of it, you know it. And last one, Julian, turn your whole body so you're focused in your packet, working with us, solving problems involving proportional relationships. Either you don't know, you've heard of it, or you know it. Okay? So I'm going to go ahead and turn to page 2, and that's where we're going to start. Now I want to show you, if you're ever absent, where you can access our curriculum things here. So it's a little wonky. Let's try this. It did kick me out. All right. So when you log into Clever, remember, you see these 2 apps after you click on the red McGraw-Hill app. You have Math 7 NYP Log 4 AB titled for both. Right now, we're not getting into ALEKS. Remember, ALEKS is personalized, tailored to you. This Reveal Math right here is going to help with your packet. So I'm going to click here. And if you weren't here, you could click there too to kind of follow along with what we're doing. You can click and view the lesson materials right here. This goes along with your packet. Now, the first few things might not start out showing you what to do, but I'll kind of try and talk you through that. So I'm going to go ahead and launch this presentation. All right. So unit rates involving ratios of fractions. In Japan, millions of people travel between locations in bullet trains along a series of high-speed rail lines known as the Shinkansen. These trains can carry passengers from the capital, Tokyo, on the east side of the island to the ancient city of Kanazawa on the west side, a distance of 282 miles in only 2.5 hours. So do you see how when we're reviewing unit rates that may be helpful? You have a certain amount of miles in a certain amount of time. I'm thinking about that right now. So let's talk about it. The train's rate can be written as a fraction. This fraction is considered a complex fraction. Why do you think this might be a complex fraction? Well, how does it compare to other fractions you have seen? And what do you think it means for it to be a complex fraction? So talk about that at your tables for just a minute. What makes it complex? Go. I hear a lot of I have no clues. That's all right. Okay, so our fraction usually looks like what? A number over a number, right? How is this different? What's different about the bottom number? Is it a regular number? No, usually we have whole numbers there. So this complex fraction, maybe because we have a mixed number, right? Or maybe because we have, it looks a little different. Maybe there'll be a fraction there instead of a mixed number. Or maybe there'll be a decimal there. I'm not sure. But we'll see in a little bit what our goal is and why that is. So here's our standards. So we're going to want to be able to say that I can find unit rates when one or both quantities are fractions. What was that, Julian? What about fractions? Nope, we have to be able to find unit rates when one or both quantities are fractions. Please stay focused. You should be on page 2 in your packet. All right, so we're going a 7th grade. See that 7 there? That means it's a standard for 7th graders to know this. 7th graders need to compute unit rates associated with ratios of fractions, including ratios of lengths, areas, and other quantities measured in like or different units. So how can I use these? So we have to be able to reason abstractly and quantitatively, right? I can make sense of quantities such as those in a unit rate. We have to attend to precision. I can use mathematical vocabulary to communicate with others. And we have to look for and make use of structure. So I can explain how the structure of a complex fraction allows me to simplify it. What do we know about the fraction bar? What does it mean? What do we say? It shows an operation. What operation does it show? Divided by, division, right? That fraction bar means divided by. Okay. Here you are at the top of page 2. What vocabulary will you learn? Well, there's a lot of vocabulary there. I want you to go ahead and look at those 6 things, those 6 terms, and put check mark boxes next to the terms that you may already know. So do you know what the constant of proportionality means? Do you know what non-proportional means? Do you know what proportion means? Do you know what proportional means or proportional relationship? And finally, do you know what a unit rate is? All right, so what are some synonyms for the term unit? Synonyms means the same. What are some things that we could say in place of unit? Guys remember playing with unit cubes when you were little? No? Yes? Like base 10? Yeah. So each unit was how many? Just one, right? It's singular. So singular, one are all things that would be the same as unit. All right, so there is a quick review there that we're gonna skip over a little bit. We've been working on this review in class. I'm going to turn to page 3 in my packet. Page 3 in my packet. Are you all with me on page 3 in your packet? Excellent. So this is just an explore. If you want to do this activity on your own, you may do so at another time, but I'm just going to walk you through it so we're all here together and it makes it go just a little bit quicker. So our inquiry question, how can you find a unit rate in which one or both quantities are fractions? Any ideas? How can we find that? All right, think about it for a second. We're gonna keep going through here. I'm hoping that this is gonna help me not to yell because I'm trying to be loud so that the Zoom recording picks me up. Otherwise, it's pretty quiet on the YouTube video, I noticed. So hopefully this is helpful. Sorry if you feel like I've been yelling at you, just trying to be loud for that reason. So 3 friends are training for a 1-mile race. Their rates are shown in the table. How long will it take Sasha to run 1 mile at her current rate? Use any method, however, be able to justify why your method works. So I want you to talk about it at your tables, explain why your method works, how many different ways were possible to solve this problem, how are all of the methods similar and different. So try and solve this problem and talk about it for just a second. Go. All right, what would you guys do? How would we solve how long it would take them to run a whole mile? What do you think? Any ideas? No ideas yet? Oh dear. Oh dear, dear, dear. I feel like Pooh Bear. So how could you use a bar diagram to find the solution? So try to draw a bar diagram that helps solve the problem and be prepared to explain why your bar diagram works. So let's see if I can annotate here. So remember, a bar diagram, we want to know what you know. We know Sasha's rate is 1/4 mile in 65 seconds. If she's going 1/4 mile in 65 seconds, can we figure out how long it takes her to run 1/2 mile? How long would it take her to run 1/2 mile in 65 seconds, Camden? Excellent. So how did you find 130 seconds? What did you do to get 130? Good. So since he knew that 2/4 were in 1/2, he multiplied this by 2. All right. So what if I wrote 3/4 for the next one? What am I adding to the 130 65. So for each quarter, it's taking her 65 seconds. So now I have 195 seconds. So how would I figure out how to find how long it took her to run 1 mile? What am I adding to the 195? 65. So you can write that in any of your notes. You have this whole top section up here on page 3. So here at the top, you've got some space. You can show a little bit of your scratch work there. I know there's going to be some times when there aren't exact locations pointed out to you, but it's good to keep it all in the same workbook so we're not having to refer back to figure things out. So, how long does it take Sasha to run a mile? We have to do 195 plus 65. So good. When I add that 5, I get to 200. And then another 60 makes 260. So 260 seconds is how long it takes her to run a whole mile. Interesting. All right, let me clear that. Pull this X out of there. No? I was trying to clear it. There we go. All right, so here is kind of what they're talking about with the bar diagram. We said it was 65 seconds here. We added 65 to get 130. We added 65 to get 195. And then we added. So what they're saying is that each quarter is 65. So if we add up all these 65s, we get our total. Does that make sense? They showed it a little bit differently. I was showing you adding 65 as we went. They're showing you how long each quarter of a mile will take her. Questions about that? It's a little different for sure. Part 5. So how could you use scaling to find Sasha's unit rate? So solve this problem using scaling. You guys know what scale factor is? We might need to walk through that a little bit. So your scale factor is what? What's your scale? For every quarter, she's taking how long? 65 seconds. So if we try to multiply them both by 4, we would use that scale. It's a little bit different. So this is just asking you to think about which method you would prefer and why. Okay. And then it kind of says, if Pedro and Emily each continue running at the same rate, how long will it take each of them to run a mile? So we're going to use any method that works. So how many thirds in a mile? 3, right? So in 2/3 of a mile, she went 200, or he went 240 seconds. He did that in 240 seconds. So how much would each third of a mile have taken him? No, that's 2/3. So 2/3 took him 240. Half of that is going to be 1/3. Does that make sense? No. So if I split this up and show you the way they did, maybe. So if he has a third, and a third, right? And this 1/3 and this 1/3, even I think maybe we need to move if we can't focus there. So these 2/3 took him how long? How long did these 2/3 take him? What does it tell us? 240. So knowing that now, Camden, do you see how long 1/3 took him? Yeah, so that makes more sense being shown that way, right? So if each one is 120, how much more do we have to add to get a whole mile? How much more do we have to add, guys? Another 120 seconds. Good. So how long did it take Pedro to run a mile? 360 seconds if he stayed at this rate. Now, Emily is running 5/6 of a mile in 275 seconds. So we could think of it in sixths again. So I have, it's a lot, isn't it? So if I have 3 pieces this time, I can separate them. So 5 of these adds up to what? 275. So how much does each 6? How do we figure out how much each 6 is? We have to divide that by what? 5. So 5 goes into 27 5 times with a remainder of 2. So we bring down the 5, 25, so 55. So 55 seconds we have to add on to the 275. You see how it's a little bit tricky, so we gotta draw the picture out. You see where I'm getting the 55 seconds from? It's saying each one of these is 55 seconds. 55 plus 55. You get it, right? Plus 55. Sorry, it takes me a while to write with my mouse. Plus 55, and it's a little messy too, for sure. Plus, not 53. Plus 55, finally. So 5 55s add up to that 275. And we found that 55 by dividing that by 5, because we knew that 5 of those 6 made that, so we can figure out what each 6 made. Is there an emergency because you're missing class for it? All right, so we added then 55 to come up with what? What's 275 plus 55? So 5 makes 280, so 320, 330. So how long did it take Sasha, do we remember? 260, and then to run a whole mile, and then it took Pedro 240 plus 120, so 360, and it took Emily 330. Then we're comparing them to how long it took them to run a mile, right? Not just parts of the mile, because that makes it hard to compare. You want to compare apples to apples. Let me quit drawing here. All right. All right, so this is just walking us through what we just did. And then you could answer it. If you wanted to check your work, if you weren't here, you could put your answer in here. So how can you find a unit rate in which one or both quantities are fractions? Think that through. So how could we do that, right? We could draw a picture, you can use a bar graph. How we did it when the first quantity was a fraction. We might do it differently when the second quantity is a fraction, but we might also be able to draw a picture and draw that out to figure out the arithmetic there, okay? All right, you guys are patiently waiting to see what you have to write, and it's coming up right now. So right where it says learn in your packet, it's going to start giving you some places to record these notes. I'm going to make this a bit smaller so we can see a bit better. All right. Unit rates involving ratios of fractions. Do you see where it says that next to learn on page 3? A recipe to make a diluted cleaning solution calls for 4 gallons of water mixed with 1/3 cup of cleaner. The ratio of gallons of water to cups of cleaner is 4 to 1/3 or 4 to 1/3. Isn't it great that we learned the 3 different ways that we can write ratios when we're doing our review? You have 1 cup of cleaner and you want to use all of it. How many gallons of water do you need to mix with 1 cup of cleaner to maintain the 4 to 1/3 ratio? So if you want to use all of the cleaner, we could find the unit rate, which is the number of gallons of water needed to mix with 1 cup of cleaner, and you can use various strategies. So explain to a partner right now why the rate 4 to 1/3 is not a unit rate. How is that not a unit rate? Who can tell us, why is that not a unit rate? Well, what's a unit? 1. Do you see 1 anywhere in there besides part of the fraction? No, that's not a unit rate. All right, you see, as I move here, it's moving in your packet. This is the top of page 4 in your packet. So turn to page 4. They even showed you where you could write down why it's not a unit rate. So go ahead and take just a second there to write down why it's not a unit rate. Remember, a unit rate is a rate of 1 quantity. So the rate of 1 quantity is our unit rate. And this is a quantity of 1/3, right? How much we need if there's a third. We want to know how much we need if there's 1. All right. Let's make it a bit smaller. So you can use a double number line to find the unit rate. The double number line shows that for every 1/3 cup of cleaner, 4 gallons of water are needed. So do you see that? It's going up by 4 every time for every third. So 12 gallons of water are needed to mix with 1 cup of water. You see where it's showing you that also in your packet. Hopefully you're able to follow along. You can use a bar diagram to find the unit rate. The bar diagram shows that 12 gallons of water are needed to mix with 1 cup of cleaner. So for every 1/3 cup of cleaner, 4 gallons of water are needed. So they are just reiterating how they got that. And it's continuing down in that learn section. So right below that in your packet, by using a ratio table to find the unit rate, you can scale forward by multiplying both 1/3 and 4 by 3. So this is a lot of what we did when we were finding the missing pieces, right? The missing proportion that we wanted, the missing quantity that we wanted in our review. So the ratio table confirms that 12 gallons of water are needed to mix with 1 cup of cleaner. So what we knew was that we wanted to get to 1/3. I'm sorry, we wanted to get to 1. So what do we multiply by 1/3 to get to 1? We had to multiply it by 3, because 3 divided by 3 equals 1, right? So if we multiply 1 part of the ratio by 3, or 1 part of the proportion by 3, we also have to multiply the other part by 3. Remember, whatever we do to the top, we have to do to the bottom. Does that make sense how they're using a ratio table? A little bit differently than drawing the bar diagram. All right, here's a third way. Oh, there 3 ways we can do this? All right, that gives you lots of options, right? Let's look at the benefit of that for sure. So you can also use division when finding a unit rate. Recall that a ratio or rate can be written in fraction form. So the ratio 4 to 1 can be written in fraction form as 4/1 here. The ratio 4 to 1/3 can be written in fraction form as 4 to 1/3. Remember, we call that a complex fraction. The expression 4/1/3 is called a complex fraction. You guys already know. A complex fraction is a fraction in which the numerator or denominator, or both, are also fractions. So because the fraction bar indicates division, you can divide the numerator, so the number on top, by the denominator, which is the number on the bottom. So we can take the top divided by the bottom to find the unit rate. So as we're looking at this fraction, 4/1/3, we know that we can say divided by for our fraction bar. So we'd read it from top to bottom, 4 divided by 1/3. When we divide and multiply by fractions, we have to change our mixed numbers and our whole numbers to a fraction. And our whole numbers we can change to a fraction by writing as that number over what? 1, right? Our whole numbers can be written over 1. So we write 4 as 4/1. And now we multiply by the multiplicative inverse of 1/3. And what that means is we're multiplying by the reciprocal. Remember, we cannot divide fractions. Instead, we keep change flip. Remember that? We keep the first fraction, change the multiplication, flip the second fraction. Yes? No? You take the reciprocal of the second. So we're keeping the first. We're changing to multiplication. See how they flipped the second fraction? It's right in your packet too. You see where they flipped them. Now we have to multiply the fractions. So we always multiply the top straight across. What's 4 times 3? 12. And 1 times 1 is 1. Anything divided by 1 is itself. So 12/1 is 12. So in other words, 4 divided by 1/3 is equal to 12. So using any of these strategies, right? Either the, what do we call that? The bar diagram, the ratio table, or division to find the unit rate, we can find that it is 12 gallons of water for every 1 cup of cleaner. That was a lot. So talk about it. How is finding a unit rate when one of the quantities is a fraction similar to finding a unit rate when both quantities are whole numbers? And how is it different? So this talk about it is on the bottom of page 4. I want you to be sure you have notes for it. Remember back. You can look in your old packet even. How do we find a unit rate? Remember our unit rate was where we divide the first quantity by the what? Second quantity. That's how we were finding the unit rate with whole numbers. It's a little trickier for sure, right? Quite a bit trickier when we're having to deal with fractions. We have to remember how our fraction operations work. We have to remember how to multiply fractions and divide fractions. And we're going to do a little bit of that in our warm-up tomorrow, I do believe. All right. So I think that's the end of that learn section. Now I want you to see a few examples. All right, so we're going to find unit rates. Example 1. Tia is painting one side of her shed. She paints 36 square feet in 45 minutes. At this rate, how many square feet can she paint each hour? So why is 45 minutes equal to 3/4 of an hour? Why is 45 minutes equal to 3/4 of an hour? Do we lose our magnets? I can still Alright, so how can we figure that out going forward? Why is 3/4 of an hour 45 minutes? How long is each quarter of an hour? Look at the clock. 15 minutes. Each one is 15 minutes. So between the 12 and the 3, that's a quarter of our clock. Between the 12 and the 9, that's 3/4 of our clock, and that's 45 minutes. So that is why 45 minutes is equal to 3/4 of an hour. Have you heard quarter after or quarter to? Hopefully. Okay. So method 1, we can use a bar diagram. So you know that 45 minutes is 3/4 of an hour. So Tia's rate is 36 square feet per 3/4 hour. So you need to find the unit rate, the number of square feet she can paint per hour. So we can draw 2 bars to model the ratio 36 to 3/4. Oh, I see. See how they got 36? And they divided them each by one of the quarters for 3/4. They divided each bar into 4 sections because 3/4 is a multiple of 4, and there are 4 sections of 1/4 in 1 hour. I know that takes a second to make sense of that. But to find the unit rate, we first find the value of each section in the bar representing square feet. So they took this 36, and since there were 3 sections, they divided it by 3 to get how much? What's 36 divided by 3? 12. So they figured out that each quarter was 12 feet. And they added on 12 more to make a whole. So the unit rate is 48 square feet per hour. Do you see what you need to put right here in this box on your sheet? What do you need to put there? How much can she paint in a whole hour? 48 square feet. So you're putting 48 right there in that box. It's under method 1. It's about 2/3 of the way down the page. Okay. So now we're moving on to method 2. We can use a double number line. So what would we put as this top number here? So they want us to move through the slides to see how a double number line can be used to find the unit rate. So the top number represents the number of hours. The bottom number represents the square feet. Do you see that? So for each quarter, they put a line there, and they know that 3/4 of an hour is 36 square feet. They put in what they knew. Now they were able to divide those 3 pieces to see that they were each 12 square feet to know what the next quarter would make was another 12 square feet. They got the same answer, right? With that other method. Method 3. So I'm turning to page 6. You have 3 methods to figure these out. That's lots of options for you. Don't get confused by them, be empowered by them, right? So using a ratio table. The ratio table shows the number of square feet painted in 3/4 of an hour. So what did they do to get from 3/4 to 1/4? What did they do? They divided that by what? 3, right? So if we scale back this way and divide them both by 3, we see how much they make in a quarter hour, which was 12. And then 12 feet were painted in 1/4 hour. So 12 for 1/4. How many quarters are there in 1? 4. So if I multiply 1/4 by 4 to make 1, what am I multiplying the 12 by? 4. So we have to scale forward to find the number of square feet. So do you see how we had a little bit of this vocabulary in our equivalent fraction and equivalent ratio review? We talked about scaling up by multiplying the same by and the same, whatever we multiplied the top by, we multiplied. We talked about scaling down, and we divided them both by the same number. We had to scale down when we were simplifying ratios. So try and remember those things. All right. Just talk about multiplying them by 4. Oh, lots of methods there. So 5, the rate 36 square feet in 3/4 hour can be written as 36 over 3/4. So here's our complex fraction. Move through the steps to simplify the complex fraction. Method 4. Like I said, guys, don't get overwhelmed by all the methods. Be empowered by them. Choose one that you like best. So we're going to use division. It says write the complex fraction as a division problem. So they have 36 divided by 3/4. Can we divide by fractions? No, we can't divide by fractions. We have to multiply by their reciprocals. It went off on me. I was too loud for it or something. All right. So we're going to then rewrite it as a multiplication problem, right? We write 36 over 1 as our fraction divided by 3/4. And we're going to keep the first, change to multiplication, and flip the second. And then we're going to multiply by the reciprocal, which is 4/3. See how they flipped the fraction? Now, when we multiply, we have 36 times 4, or you could have cross-canceled here and had 12 times 4. And our unit rate is still, Kim Paint, what, 48. That goes in, oh no, they don't even have a blank for you there. So check. Tomorrow, we're gonna start with the check. Doug entered a canoe race. He paddled 5 miles in 2/3 hour. What is his average speed in miles per hour? And you can use any one of these strategies. So that's where we're starting tomorrow. On when? Oh, today's Wednesday. On Thursday. Reminder, I won't be here tomorrow and the next day. Okay, well, follow along in Google Classroom when you're gone. All right, so that's where we're starting up. Tomorrow is with our check. Questions, concerns so far? Hopefully we're getting there and understanding. I have this little bar here. All right. Guys, you did well. Have a wonderful, fantastic Wednesday.